Okay, so maybe you can turn on your caption, and so that you can try. Or maybe because of the ray, so we may have the lag. All right. Oh, wait a moment. So you can turn on the caption, and so that you can check the caption, possibly. And this Monday, actually, we already have the discussion from problem 2 to problem 5. And finally, I already have the solution quickly. And before we end the good discussion, then we ask you to have these. So about the discussion about web and HTTP, we finished some discussion. And actually, we already know non-persistent, persistent, and also non-persistent with parallel connections. All right, so up to now we have 3 versions. So here we have the illustration about non-persistent HTTP. We need to have the connection for each object. And we have one base file, and the base file with 10 reference images, and so that we have 10 objects as well. And because we need to have the response time, and we define RTT, right? RTT is cool, it's cool transmission delay, but in fact RTT include the other 3 types of delays, including processing delay, queuing delay, and propagation delay. So we have the 3 delays included in the RTT. However, we still need to have the calculation for transmission delay if we need to further calculate the response time. All right, so I think we already know these on this Monday. And we have persistent, and then you know how to have the operation for persistent HTTP. And in fact, we already have the possible time. If we have non-persistent HTTP, then we need to have 2 RTTs plus the transmission delay for each object, because we have the connection for each object. However, for the persistent HTTP, we need to have the connection open for the first object. That says the base file, right? And after that one, keep open. So we keep open, keep the connection open, and we can request the remaining objects. And likewise, later we can already have 10 objects. All right, so we want to request the object by using pipelining. All right, so later we have persistent HTTP, and we assume we have a pipelining. And actually, we have non-persistent with parallel connections. So up to now, we have 3 different ways to have the connection to download the objects. All right, so right now, we already have this example and check the response time for the 3 ways to have the connection. All right, so up to now, let us check it. And again, for all of you check, can you see the current PDF annotator? If yes, then the current problem is we have one base file plus 10 image. Here we have 10 objects. And we assume with the same size All right, so right now we have the given information. And we want to have the calculation for response time. So first one, non-persistent. HTTP. If we have a non-persistent HTTP, how to have the calculation? And if possible, you can review. You can review the previous pages about the response time by using RTT. So here, first of all, this is a client, and this is server, right? And we need to have RTT open to request the connection, and then request a file. Pass file, right? And so that we have RTT. And here we assume the object, the size of pass file. We have O over R. So actually here, we still need to assume capacity of a link. It's R. All right, so we assume the same capacity R, and only the single link. Somehow like we have the transmission delay O over R. All right, so if we have a non-persistent for the batch file, the response time is 2 RTT, and we have the transmission delay O over R. All right, so this is the response time, and because non-persistent, we need to repeat for the remaining connection. So for 10 objects, the response time. Okay, response time. All right, so response time equal to 2 RTT plus transmission delay per object, right? Up to now, I think you can understand we assume the same size for the batch file and for the image or for the object. So of course, we have the same response time for batch file and for the 10 objects. So it says per object, simply we call per object, we have the response time 2 RTT plus O over R. Therefore, the overall response time equal to 1 for the batch file plus 10 objects, the same, and plus the transmission delay. Finally, we have 11. Therefore, this is the answer to the first case, non-persistent HTTP. Up to now, I think it's really trivial, right? You simply count how many objects? We have 11 objects, so each object we have the response time 2 RTT plus O over R. Well, up to now, is it okay? All right, seems to be okay. So I assume I can continue to check the next one. And before I continue the next one, so I already have the actual one. So change it to mute, or anyone, switch anyone to the mute mode. So anyone can check and help me. All right, so here I just continue. And so we have the same response time for the first image, second image, and the 10th image. Here we have the 10th object. Why? Because of non-persistent HTTP, we need to have the connection to download the other objects, right? So because of this, we need to accumulate all the response time. And finally, we have 11. This is the first one. And the second one, that does have non-persistent, but with parallel connection. If we have these, we assume non-persistent with a parallel connection. And also we have perfect synchronization. That says we have these. Client, server. Here. That's file. And likewise, we have these. All right, so RTT, O over R, right? And about the multiple connection, in fact, if you refer to the exercise, maybe you have the restriction about the number of simultaneous connection. But right now, we assume we can have the parallel connection as many as possible. Let's say right now we have 10 objects, so we can have 10 parallel connections to download the images directly. So here we have these. First object, second object, 10th object. And we assume perfect synchronization. So it says to download the first object, second object, 10th object, we have the same response time. Because of this, so this time, follow the previous discussion. How to have the overall response time. This time, we have 1, 2 RTT plus this. It's the best file. And plus same, only 1, 2 RTT plus O over, sorry, it's R. And here, 1 to 10th object. Why? Only 1, because we assume multiple connection, and we can have the perfect synchronization. Therefore, only 1 actual 2 RTT plus over R. So finally, we have these. All right, if I expand, we have 4 RTT plus 2 O over R. That's all. So for the parallel connection, here we assume we can have the multiple connection as many as possible. And also we assume for each object the same, the actual objects, we have the same response time, 2 RTT plus O over R, and so that we simply have 1 for any one of the response time to download the object. Therefore, we have the final solution, 4 RTT plus 2 O over R. That's all. So up to now, for the second case, any questions? No, right? So that's it. And finally, let us check persistent plus parallel. Sorry, not parallel. Pipelining. All right, if we have these, client, server. So first of all, same RTT, RTT, and here we have O over R. And we have these, and then leave the connection open. All right, leave connection open. That says, should we have the request to open the connection? No. So next time, request 1 to 10 objects simultaneously. Actually, maybe not simultaneously. At least request the 10 objects. Request the 10 objects here. Look at these 10 objects. So we can have first one, O over S, first object, and first object, second one to 10th one. So here we have pipelining. All right, so if we have this, and then it says we have the gap. All right, and finally, because of the limited space, so let me use this color. So finally, total response time. So of course, still we have 2 RTT plus O over R. Same, this one for base file. As for the remaining objects, only 1 RTT. All right, this one request. Right? And plus the transmission delay. All right, so if so, finally we have for the solution 3 RTT and plus 11. Here you see 11 O over R. Okay, so up to now, if we have a persistent plus pipelining, this time we only have 3 RTT. However, we cannot eliminate any transmission delay, so we still have 11 O over R. So about the transmission delay, we cannot skip anyone, and therefore we still have 11 O over R. Here we have the solution for this case, persistent HTTP plus pipelining. About the current derivation, is it okay? Well, if that's okay, and then that's the actual discussion. I think that's all. And let me save it. So this is the HTTP response time. All right, so I can upload the handwriting about the further derivation for you. And I think at least right now, let me know everything's okay. All right, so later, same, I ask you to let me know. So wait a moment.